Hello. To science concepts, the number that Charanya has. Yeah, it's our number. It's an admin number. Okay, children, good evening. So, how are you? This is, I don't know how many days of lockdown today, maybe today is 21st, so it's almost a month of lockdown, right? So, today we are going to, some of you asked, like, will we learn something new? So, yes, today we are going to talk about refraction. Okay, we'll talk about refraction. We will talk about, we'll talk about some laws of refraction. How does refraction happen? Then we will talk about lenses, and many of you. So I use glasses. So because my eyesight is not perfect, so a lot of us use glasses. So we'll get to understand, how lenses work, and also do some ray diagram and some calculations, right? So at the end of that, we will have a very good understanding of how reflection and refraction works for both mirrors and for lenses. Okay, so let's get started now. So let's go. Okay, so okay, there we go. So now we will start very gently. I'll go slowly. So feel free to stop, ask questions, and so on. Okay. Now, first question for you is: imagine, right? Imagine that this is, let us say, a slab of glass. Okay, this is a slab of glass. Okay, and a ray of light falls on it. So let's say there is a torch or something here, right? And this torch is sending a ray of light. So there is a ray of light going like this, and the question is, what happens, right? So if you observe this now, in fact, I have done these experiments, so I can show you some videos. But right now, obviously, because of lockdown and all that, we are not able to do that. But when the lockdown is over, I'll send you some beautiful experimental videos where a lot of things that I'm talking about you'll be able to actually see in experiments. Okay. For now, you'll have to just take my word for it. When this ray goes, what happens? Normally, light travels in straight line, right? So if you use that logic, you should say, okay, this ray will go like this. But experimentally, it's found that this is not the case. Okay, so the ray of light does not go straight like this. What happens? I'll tell you what happens. So this ray of light will bend a little bit. Okay, so what would happen is, instead of going like this, okay, so instead of going like this, what it will do is, if I'll draw a line which is perpendicular to the surface. Okay, so I will draw a line which is perpendicular, and instead of going like this ray will bend towards this blue line. Okay, it will bend towards this blue line. So instead of going like this, it will bend towards this. This is what we are talking about. Okay, and this ray, okay, and this blue line, it's given a name. What is the name, children? Can you tell me what the name is? This blue line which is perpendicular to the surface, what do we call it? Yes, you are right. We call it the normal. Okay, so this is called normal. Normally means what? Normal means, sadharan or whatever, like regular stuff, right? Here normal means a line which makes an angle of 90 degrees. Okay, that is what the meaning of normal is. Okay, so now what happens is, we observe that this ray will bend towards the normal. This is an observation. This we find experimentally. So now the question is, how much does it bend? Great question, right? And if, let us say, the ray was not coming like this, let's say it came like this. So there is this angle, okay, this angle I, okay, this angle I, we call it the angle of incidence. Okay, so this angle we will call the angle of incidence. Incidence. You don't have to take notes, just observe it, and later on I'll give you time to take notes, and I'll tell you how to take notes. Okay, so this is called angle of incidence, and this angle here, I'll call it R. Okay, this is R. This angle is called the angle of refraction. Angle of refraction. Okay, now it turns out that the angle of incidence is not equal to angle of refraction. So if they are not equal, then the question is, what is the relationship? So I, let me use the same color red, I and R, do they have a relationship? This is a question. Okay, now this question people have answered experimentally, and there is a law. Okay, now I'll have to use a little bit of trigonometry, just a little bit, so don't get scared. Okay, this is very, very basic idea. Okay, so I will use something called sine theta. Okay, so if you do not know what sine is, you can ask me, I'll explain that. Please let me know. Okay, I will continue, but if I see that you don't understand sine theta, I will stop for a minute and explain that to you. You can ask me. So now people found experimentally that yes, there is a relationship. I and R, they are related. And what is the relationship? So the relationship is that doesn't matter how the ray comes. So let us say we showed one ray like this. Right? I take different rays. So let's say I take a ray like this. I take a ray like this. I can take any number of rays. Right? All these rays, they will get refracted. They will go at different angles. Right? But one thing which you find is that I and R always have one thing which is, just let me make sure that you guys are able to hear me. Yeah, I think the volume is correct. Okay, so so sine of I upon sine of R, sine of I upon sine of R, this is equal to constant. This is the relationship that people have found experimentally. Okay, so if you don't know what sine is, I will take a few minutes to explain to you what sine is. Does anyone know what sine is, or do all of you, or you have not, you're not familiar? Let me know. Let me know. Okay, so I will very quickly I will explain to you what sine means. Okay, so let us now take a triangle. Okay, let us take a triangle, and we'll take a special triangle, a special case of a triangle where the angle between two sides is 90 degree. Okay, so the angle between this side and this side is 90 degree. Okay, now here I can take, I can take multiple triangles. So let us say I take this triangle, I'm calling it A, B and C, right? I can take another triangle which is, let us say, like this, right? So I will call this this point B1 and this point, it's a C1. So I can take a triangle ABC, or I can take a triangle AB1 C1, doesn't matter. Whichever triangle I take, we will find that the okay. So a lot of you are saying that you have not studied trigonometry, or you don't know about sine, so it doesn't matter. I'll just explain to you very gently. Okay, so we find that the ratio, if you look at this angle, let's say this is an angle, I can give it any name. Let me call it theta. Now some of you must be wondering, why are we calling, till now we were all talking x, y, z. Why are we calling it theta? Why can't we call it x or y or a or b or c or p, q, whatever? So we can. Okay, it is just a convention. So don't think of theta as something new. I could have very well called this. X, X or Y or P or Q. I could have called it any of those names, but conventionally we just call it theta. So please don't get confused because of that. Okay, so we'll just call it theta. Now it turns out that if I take the ratio of two sides, if I take the ratio of AC, okay, let me do one thing. Let me actually even make it simpler. I will get rid of your, I'll just take the triangle ABC now. Okay, so now if I take the ratio of, so there, okay, first of all we'll give names to all these sides. Okay, so when you have a triangle like this, okay, there are two sides here. So there is this side BC and there is this side AC, and the angle between them is 90 degree. Okay, so here we will call okay, Anant, you have a question? If you have a question, you can ask me. So this side we will call base. Okay, and this side so if this angle is theta, once again, if this angle is theta, the side which is touching this theta, okay, which is touching the angle, but this side which is also part of the, see there are two perpendicular arms, right? So the perpendicular arm which is touching the theta, we will call it base, and the one side which is opposite this, okay, the side which is opposite theta, we call it perpendicular. Okay, once again, there are two arms between, there are two sides between which the angle is 90 degree. There is one side which is touching the angle that we are talking about, other side which is opposite to the angle. So the opposite is called perpendicular, and the side which is touching is called the base. Okay, and finally the third side, okay, this third side, it is given a name, it is called hypotenuse. Okay, You guys must be wondering, why these weird names. So yeah, so I understand these names are sort of weird, but they come because of all these Greek names. So a lot of this trigonometry was developed by ancient Greeks and all that. So some of their traditions have struck, but you'll get used to it, right? So there are three sides. We have base, we have perpendicular, we have hypotenuse, and now it turns out that let us see if I take different types of triangle. Here I've taken just one triangle, right? Now let us see if I take a different triangle which is let's say like this. Right? I take another triangle which is like this. Now I know this angle here. I'm calling it theta. Let us say I call this alpha. Let us say I call this beta. Right? The question is when this angle changes. Okay. One second. Let me just make sure that you guys are getting a clear signal. In case there is any problem in listening to me, please message me and let me know. Okay. Sometimes my internet at my house creates problems. It has done today. It seems to be okay, but if there's a problem, let me know. Okay. So now if you see, now the question I can ask is, look, if I change the theta, right? Here this was theta. Now this angle alpha is more than theta. This angle beta is less than theta. And if I change this angle, then what is the ratio of the sides? Right? Sir, can you make your sound clear, please? Okay. And are you able to not hear me? Okay. Is it clear now? Hello. Hello. Let me see. I think right now it should be clear, but please confirm. Okay. Let me just see if there is a problem here. Now no problem. Okay, good. Okay, cool. Okay, so now here the question is, as this theta changes, right? In fact, I can show it in this diagram itself. Let us say I take, if I take a line like this, or if I take a line like, if I take this, or if I take, let's say, a triangle like this, right? So here for each of those, the angle, I can take this line, I can move it up or down, I can change this angle. So the question is, as I change the angle, how does the ratio of the sides change? Right? That is the question that we can ask. Okay. So now what we'll do is, we will give the ratios a certain name. Okay. So now we have, I'll just remove these. Okay. Now we have a simple triangle, and I will get rid of these two. Oops, sorry. I'll get rid of these two also. Okay. Now we will give a ratio. We will give a name to the ratio of these sides. So let's call this perpendicular is P, base we will call B, and hypotenuse we will call H. Okay. So perpendicular upon hypotenuse. Perpendicular upon hypotenuse. This is called sine of theta. Why is it called sine of theta? See, this ratio, this perpendicular upon hypotenuse, it depends only upon this angle theta. Okay. If I were to take another triangle, okay, once again let me illustrate this. This is not a maths class, so I'm not going into a lot of detail, but still I want to give you some idea. Let's say if I took a triangle like this. Okay. If I took this triangle, this. If I took this green triangle, here in both the triangles, in this triangle and green triangle as well as black triangle, the angle theta is the same, right? So which means if I took the ratio of this side divided by this side, or this divided by this, I will always have the same ratio, which means the ratio of the perpendicular upon hypotenuse, right? Perpendicular upon hypotenuse, it depends only upon theta. Okay, so it is a function of theta, and we will call it sine theta. Okay, so sine theta is equal to perpendicular upon hypotenuse. Okay, and I'll give it two more. Base upon hypotenuse is equal to cos theta, and perpendicular upon base is equal to tan theta. Okay. Now the thing is, you might say, oh my god, this is like so complicated, there are so many things. Don't worry, right now all you need to know is that perpendicular upon hypotenuse is equal to sine theta. That's enough. I'm not teaching maths. When we teach maths, we'll do it in full detail. Okay. So sine theta is nothing but equal to perpendicular upon hypotenuse. That's it. Nothing more. This is more than enough for you. Okay. So sine of I means, what does sine of I means? It means if I draw a triangle where this I is this theta, then the ratio of this by this is going to be sine theta. That's all you need to know. Now let's go here, right? So now what we found experimentally is that sine I upon sine R is equal to some constant. And what does this constant depend upon? So here's a question. Let us say if I have a glass here. Okay, this is glass. Okay, and here let us say a ray of light is coming at an angle equal to, let us say, I. Okay. Now I'm going to do one thing. I'm going to copy this whole thing. Yes, and I'm going to keep it here. Okay. Now let us say this is 1 second. Okay. Now this is not glass. Now this is water. Okay. Now here's a question for you. Even this ray comes here, let us say this ray, instead of going like this, okay, it bends and it forms a different angle, and this angle is R. The question is, here also, instead of going like this, it will bend and it will form some other angle. It will form some angle. The question I'm going to ask you is this angle equal to this angle? Yes or no? What do you think? I know you don't know that. Okay, there's some problem with hearing. Oh, children, can you hear me? Hello. Okay, now I think it's clear. Okay, if it's not clear, tell me there's any portion, I can repeat that. Okay, now my question to you is, here we have glass. So this is air. Okay, this is air. This is air. This is air. Right? But the difference is, here it is glass and here it is water. The question is, will this angle and this angle, will they be the same? This angle and this angle, right? Will the two angles be the same? Same? Question mark. Yes or no? What do you think? And the answer is no. Okay. So again, how do you know that? We don't know that. We can only find it through experiments. When you do experiments, you will find that they are not the same. Okay. So then what do the question is, if they are not the same, then what does it depend upon? It has to depend upon something. Right? So it turns out, again, the proof of this will be given to you in class 11. Right now, I cannot give you the proof. It is a little complicated. I'll just have to tell you. Okay. Right now, I can tell you this, that the sine I upon sine R, this is equal to the velocity of light. So let's say I call this medium 1 and I call this medium 2. Okay, this is medium 1, medium 2. Here the velocity of light is v1. Here the velocity of light is v2. Okay, so sine I upon sine R is equal to v1 upon v2. This is found this we can find experimentally, and we can show it in the higher, in your class 11, but not right now. Okay, so and remember, for a given medium, right, when you have air and glass, the speed of air is fixed, speed of glass is the speed of light in glass is fixed, speed of light in air is also given. So for a given set of medium, this v1 upon v2 will be constant. But if I go from glass to air, then this v2 will change. Okay, so now we know that sine I upon sine R is equal to v1 upon v2. Okay, this is very, very important. Right, this is something that I want you to kind of take your time and just sort of remember this, that sine I upon sine R is equal to v1 upon v2. Okay. Now one more thing. Okay. Now one more thing. This V1 upon V2, right? V1 upon V2, we give it a name. We call it refractive index of medium 2 with respect to 1. I know it's a little complicated. You'll see, oh my God, like all these things. Why are we calling it all this? It's too, yeah, it's a it'll be a little difficult initially, but you will get used to it. Okay. So V1 upon V2 is equal to N2 upon, sorry, we call it refractive index of medium 2 with respect to 1. Okay, once again, V1 upon V2 is called refractive index of medium 2 with respect to 1. So I'm going to write it full form here. This is called refractive index of medium 2 with respect to 1. Okay. Now what I want you to do, I want you to now take notes. Okay. So this page and this page, I would like you to take notes. I'll give you a couple of minutes. The way to take notes is please do not copy from the screen. You have to be able to understand and write it. Okay, so 1 second, stream status. Why is it poor? Screen is lagging. Okay. Why is it lagging? Let's just wait for screen to recover. Now I think it should be fine. Is it better now? Children, is it better now? Hello. Now I think should be fine. Okay. So I would like you to just take notes and you should write it in your own words. First I want you to write that uh, draw like two parallel lines, normal, and then sin I upon sin r. And first observation is sin I upon sin r is equal to constant, and then second is when you have two different medium, right? The sin I upon sin r. So the angle of refraction, even if the incident angle is same, the angle of refraction is not the same, and the ratio is equal to V1 upon V2, and V1 upon V2 is called the refractive index. Take a minute or so and just write it down. Okay. Once you've taken your notes, please type in the chat window, say that you're finished, and then we will proceed from here. Okay, children, take the notes, and then after that, first page, I want you to draw this diagram I and R, and the observation is that sin I upon sin R is equal to constant. And second page, we observe that this sin I upon sin R, it is not the same for different medium. It depends upon which two medium, and this is equal to the ratio of V1 upon V2. And finally, V1 upon V2, we give it a name. We just call it refractive index of medium 2 with respect to 1. Remember, it is not refractive index of medium 1 with respect to 2. It is refractive index of medium 2 with respect to 1. Children, please let me know when the note taking is finished. Okay, good. So now let's go to the next step. Everybody has done that? Okay. Now when a ray of light comes like this, and after refraction, let's say it bends like this, we have seen that if this angle is I and this angle is R, and here the speed is V1 and here the speed is V2, right? Then we found that sine I upon sine R is equal to V1 upon V2, and we call this refractive index of 2 with respect to 1. Right? Now let us say medium. Let's take a case where medium 1 is air, right? Medium 1 is either air or vacuum, and both have almost the same speed of air, right? So the speed of air in vacuum is a fixed speed. Okay, speed of light. What am I saying? Speed of light. Speed of light in vacuum. Okay? Vacuum. This is a fixed number, and we give it a name. We normally use a symbol C for that. Okay, and C is equal to 3 into 10 to the power 8 meters per second. Okay. Now just say this. So now let's say if my V1 is equal to C. Okay. If my V1 is equal to C, then what happens? Then essentially, then my V1 upon V2 is nothing but C upon V2, and this is the refractive index of medium 2 with respect to vacuum. Okay, but normally we will not write this vacuum. We will just call it refractive index of medium 2. Okay, once again, when the first medium is air or vacuum, when this is air or vacuum, then the speed V1 is equal to C, and instead of calling it refractive index of medium 2 with respect to vacuum, we will just call it refractive index of medium 2. So when somebody says refractive index of some material is, let us say is 1.2, they are not saying refractive index with respect to what. It always means refractive index with respect to vacuum. Okay, so I will just write it here. So refractive index with respect to vacuum is just called refractive index. We don't say with respect to vacuum. just called refractive index. Okay, there's some problem again. Okay, let me just wait and see. I think now it should be okay. No, in between, yeah. So there's some problem with the audio. It's a children's fluctuating a little bit, but I'm hoping you can hear me now. Okay. Can't help it totally, but I think you're probably able to hear most of it now. Okay, so I'll just repeat what I said. So what I said is that V1 upon V2, okay, this is called refractive index of medium 2 with respect to 1. But when your medium 1 is vacuum, then V1 becomes C. C is the speed of light in vacuum. Then instead of calling it refractive index of medium 2 with respect to vacuum, we will just call it refractive index of medium 2. So here this is what I've said. Refractive index with respect to vacuum is just called refractive index. This is just a convention. So when summers, so now let us say if you are wearing glasses, okay, those of you who wear glasses, you may have, okay, there's a problem with the voice. Is there a problem with the voice? Can you guys, okay, now I think should be okay. I know in between it's fluctuating, but now it should be all right. Okay. So this is so now okay. Let me. I was saying something. So let's say you go to a ophthalmologist class, and let's say there is they show you different lenses. So if you next time when you do that, just notice they'll give you a booklet or something where they will give you choices. You can take this glass. It has got a refractive index of 1.6. Something is 1.65, 1.7, 1.72. Right. So the higher the refractive index, the more costly it is. Right? And there they will not say when it says refractive index of 1.65 or 1.7. What does it mean? It means the refractive index is with respect to vacuum. Okay, so we don't have to say with respect to vacuum, but if nothing is said, it is understood that refractive index is with respect to vacuum. Okay, this is the basic idea. Now I want to move on to something more interesting. If you have any questions, okay, I'll stop here. Please take notes. Again, please do not never copy from the screen directly. Think and then write it in your own words. Okay, I want you to once again, I want you to think, understand, and then write it in your own words. When you're done writing, please put the comments in the comments that you have finished, and then I will go to the next topic. Okay, children, take down. I'll give you 1 minute. Please take the notes, and then we will go to the next topic. If my voice is not very clear, I will repeat it. Don't worry. You'll be able to understand that. Okay. Finish the notes, children. Then we'll go to the next topic. Okay, children, have you finished the notes? Can we go to the next topic? Now we'll talk about something more interesting. We'll talk about application of this, right, which is for spherical lenses. Okay, so let me start on that. Okay, so now I have a question for you. Right? Now earlier we talked about spherical mirrors. Now let us say I take an object like this. Let me draw it nicely. Okay. I take an object like this. Okay, and this is made of, let us say, glass. This is made of glass. Now, first question: if a ray of light falls here at some point, right, what will happen? Think carefully and tell me. Remember, we talked about the law of refraction, right, which was that sine I upon sine r is equal to some constant. Let me write this cleanly. Is equal to some constant. Okay. So now, when this ray of light falls, what will happen? Essentially, it'll follow the same law. But then, how will it follow this law? There we took a flat surface. This is sort of bending. It doesn't matter. What we can do is we can draw a line. If I draw, take the tangent here. If I draw a normal, right, normal like this, then for with respect to this, then here it will behave in the same manner. So it will bend towards the normal like this, right? So, but this seems very complicated, right? That okay, for every point, we'll have to draw the normal and find out, where the light is going. That seems pretty difficult. So we will simplify it and give you certain rules. Okay, and the derivation again, the derivation of this will come in higher classes. For now, I will give you a couple of rules. You just follow, and you'll be perfectly fine. Okay. So we are now talking about spherical mirrors. Why spherical? Spherical because this can be considered part of a sphere. Okay, so this has got a spherical shape, and this also has got a spherical shape. Let me actually draw this nicely and show it to you. I want to draw this nicely. Okay, I will draw this here. Okay, now this particular thing can be thought of as part of a sphere like this. Okay, and this can be thought of as part of a sphere like this, right? So these two, this surface as well as this surface, both of them are part of two spheres, right? And therefore this is a spherical lens. Okay, so when people spherical lens, don't get confused, like, why is it spherical? It is bent like it's not a spherical shape. Yeah, it is not spherical shape, but both the surfaces are as if they were cut from a sphere. Geometrically they will look like that. And so this is called a spherical lens. Spherical sorry, spelling wrong. Spherical lens. Okay. Now next, okay, what I'll do is I'll give you like 30 seconds. Please write this down. Okay, just not much. I mean, this is like I've hardly taught anything. Just very basic idea. So just show that when the light comes, it will bend. It will follow the same law, and and this is both the surfaces, they are like part of a sphere. So so we call it a spherical lens. After that, some more interesting stuff will happen. Okay. Okay, now let's now look at the behavior of light. What happens when light hits a when light comes in contact or light uh, crosses a spherical mirror. Okay, so let's now figure that out. Again, we'll have four very simple laws. Let's first start with a mirror which looks like this. Okay, a mirror which looks like this, and this mirror we'll call it it's called a convex mirror. This is called a convex mirror. Okay, convex lens. It's part of, so it's a lens made of both. So you told this is part of two sphere, and thus called spherical lenses. So this lens made of both concave and convex. No, answer to your question, these surfaces, they are not made of sphere. The shape is such that you can think the shape has come from a sphere. It is not actually made from a sphere, and this lens, the lens which has got shape like this on both sides, this is called a convex lens. Okay, so this one is a convex lens. Okay, and this lens which is like this. Once again, let me draw this nicely. Yeah, this lens is called a concave lens. Okay. When we're thinking about a concave or convex lens, don't look at each surface. Oh, this is concave, this is convex. Not like that, right? So this lens is called convex lens, and this lens is called concave lens. Okay. Cool. So now, when we have a convex mirror, first question. I'll go through this very quickly because we have done this for mirror. So sorry, this is not, my apologies. My big mistake I made. I'm sorry about it. This is not a convex mirror. This is a convex lens. Okay. First thing is, actually I don't like this. Let me do one thing. So let me draw it neatly in bigger. I'll draw it slightly bigger. Okay. So this is a convex lens, and this is the center. Now, in case of a mirror, okay, this center was called a pole. Here, this is not called a pole. The center is called optical center. There's a small difference. Okay, this is called optical center. Okay. What about this line? What is the line called? This line is called principal axis. Same as in the case of a mirror. Principal axis. Okay. Now first question is, what happens? I'll draw another lens here. Okay. First question. If a ray of light, if let's say parallel rays of light come, this is one ray, this is second ray, this is third ray, right? Rays of light are coming parallel. How will they come parallel? They will come parallel when the object is very, very far. Object is very far, we'll say object is at infinity, which means practically it is very, very far. When the object is very far, all the rays will come parallel, and then what happens after they go through the lens? So they will have a refraction here, so they have a refraction at this surface, and then again at this surface. But don't worry about each refraction, just follow this law. That after refraction, all the rays, they will meet at a particular point. Okay, so the rays, we will show that they'll come like this up to this point. Okay, and then we'll say that they will bend and go to this point like this. Now notice, I'm showing it coming inside, but here it's not like it will not go straight in. It will not go like straight in, then bend from here. It will bend here and here. It will bend twice. But normally when drawing just for simplicity, we will show it coming to the middle and then bending here. Okay. But the point is, parallel rays, they will all meet at a point, and this point is called the focus. This is called focus. Okay. And this distance is called focal length. I will ask you questions. Don't worry. Right now, I know what you're saying. What Rohit is saying is correct, and what you guys are saying is correct. But I need to give you some basic idea. Then I'll ask you questions. Okay. So here we have parallel rays coming, and they meet at this point, which is called focus. Right. Okay. So now let me ask a simple question. Okay. Very simple question. Uh, which is, let us say there is a lens like this, and there's an object which is very, very far. Object is at infinity, and the image of the object is formed at a point which is, say, 30 centimeters to the right. Okay, so all the rays coming from here, they all meet at a point which is 30 centimeters to the right. The question is, what is the focal length? Focal length is equal to how much? Now I'll also have to bring in the sign convention. You'll tell me is if the focal length is equal to 30, is it plus 30 or minus 30? What do you think? Think carefully and tell me. If the object is the focal length plus 30 or minus 30? Okay, so the answer is correct. It is going to be plus 30. So remember there, okay, in fact we'll come to that later. So why is it plus 30? Because we follow the same sign convention. This is going to be our origin. Okay, if I draw it here, this is origin. All distances here are going to be plus. All distances here are going to be minus. Everything up is going to be plus. Everything down is going to be minus. Okay, so this is going to be plus 30. Does it make sense? So we'll follow the same sign convention. Okay, the origin, I'll not repeat it, very, very easy, right? Origin is 0, this side is right is positive, left is negative, up is positive, down is negative. That's it. Okay, so very, I know it's a simple question. Right now I can't ask you more complicated questions. I'll ask you when we when we have taught a little bit more. Okay. Now second is now, let us say I have a convex lens here, and now I need to now do ray diagrams. Okay, so now let us say I have an object like we had in case of mirrors. I want to find where is the image formed. What will we do? I'll not repeat because I've taught you already. We can take multiple rays from here and see where do all the rays meet. But I'm just telling you that wherever two rays meet, all the rest of the rays also will meet at the same point. So we'll just take two rays and we will find where the two rays meet. Wherever they meet, that is where the image will be formed. That's a basic idea. Okay. So now what we can do is now let's say this is the mirror. Sorry, this is the lens. This is oops, my apologies. This is the convex lens, and this is the focus. So now we need to take multiple rays and look at their behavior. So first is, a ray which comes parallel, okay, a ray which comes parallel to the principal axis, what will it do after reflection? Sorry, after refraction? It will go through the focus. Okay, so this is the behavior number 1. Okay, a ray parallel to principal axis will go through the focus. Number 2. This is a, let me draw it a little bit nicely. Okay, the object here. Number 2 is a ray which goes through the optical center. This is O, optical center, will go without any deviation. There will be no deviation. Okay, so ray through optical center, it will have no deviation. Okay, this is the observation number 2. So we know the behavior of two types of rays, right? So one is which goes through the which goes parallel, goes to focus, and second which goes through the optical center, there is no deviation. Third is a ray are you able to hear me clearly? Can you just all of you confirm that you are able to hear me clearly? So okay, is it? I'm wondering if you are able to hear me or not. Please confirm. Can you hear me? Hello? Now it should be fine, right? No? Hello? Can you hear me now? Can you hear me? Hello, hello, hello. Hello, children. Okay, anyway, so let me just finish this. Okay, and the third is when, now this is a lens. Oops, I'll draw it nicely. Now let us say this distance, this is my focus. Okay, if I take the same distance here, right? By the way, this is called the first principal focus. This is called the second principal focus. Why is it called first? Because when the light is coming from here, we always take the object conventionally. We take the object on the left side. So when the light is coming from here, it will meet this focus to shows up first. So this is called the first principal focus. This is called the second principal focus. Let me just write it down. This is the first principal focus, and this is called the second principal focus. Okay, so now when a ray of light, now let's say if I have an object here, okay, I can take one ray which goes through the focus, right? So let us say if I take a ray which goes through the focus like this, After refraction, what will happen? This ray will become parallel to the principal axis. This is the third behavior. Okay, so there are these three types of rays that we'll be using, okay, for our ray tracing. One is ray parallel to the principal axis will go through the focus. Ray through the optical center will go without any deviation. And oops, sorry, just give me 1 second. I'll just delete 2 pages. Okay. Uh, So ray which is parallel to the principal axis will go through focus. Ray through the optical center goes without any deviation, and ray through the focus will become parallel after refraction. These are the three types of behavior that we will see, and next class we will talk about how to use them to do the ray tracing. I have discussed only convex lens. Next time we will talk about concave lens also. Okay. So children, thank you for watching. Sorry about the technical, sorry about the disturbance. I think there was sometimes we had the internet issues. So, but I'm hoping that you understood most of it. Also, today's class was a lot of new concepts, so I could not give you a lot of problems or ask you a lot of questions. So, next time we will start. I'll start asking you questions, so it will become more interesting. Okay. Thanks for watching, and if you have any questions, you can ask me. Thank you, everyone, and yeah, I'll see you again soon. Thanks. Bye bye.
Hello guys.
that kind of thinking. No, I'm not tired. I'm not tired to figure out new stuff. I'm actually feeling better even though we are